Okay, next thing that we have to do here is to determine the n term. So we already know how to determine the n term of an arithmetic sequence, which is linear. We already know how to determine the n term of a quadratic pattern. Now we're going to also learn how to determine the n term of a geometric pattern. Now the linear and the geometric, they have something in common. A, in both of them, it represents the first term. A here represents the first term. And then this one here, we have what we call the common difference. And then this side here, we have R instead of N, but we have R. So what does R represent? It represents what we call the constant. It's a ratio. Now, remember, when we're busy with quadratic A is not the first term. When we're busy with the quadratic pattern, A is not the first term. Now, what is A when we're dealing with the quadratic? What is A? It's half of the second common difference. Okay? Yeah, our A is half of the second common difference. So that's what we have to do now. We know how to determine this next two terms. Okay? The next thing that we're supposed to know now is know how to determine the general term. Okay. So if we consider the following patterns that we've already done, we already know something about them. Yes. So we already used this example before. We said if I say this one subtract this one, I get 5. And if I say this one subtract this one, what do I get? I get 3. This one subtract this one, it's 1. Then we saw which it was not linear. R, it's a constant ratio. It is a ratio. Okay, now we already saw with this thing here, it's not linear. Let's check the next one then. If we say 5 minus 3, we got what? 2. Ne? And we say this one subtract this one, we got what? 2. What kind of a pattern is this one? So this one, it's a quadratic. Now, if it's a quadratic, we have these formulas. Now we just have to check which one are we going to use. We have formula number 1, we have formula number 2, we have formula number 3. Which one are we going to use? We're going to use formula number what? Number 3. So we write formula number 3. And then we say, okay, on formula number 3, it says which we have Tn, which is given as an squared plus bn plus c. Now, what is our job now? Is to find A, is to find B, is to find what? C. Now, how do you get A? You say 2A is going to be given by whatever the second difference is. So what is our second difference in this case? It's 2. Then you say divide by 2. Divide by 2. It says which A is going to be equal to what? 2? 1. And then after that, we need to get B. We got A again. How do you get B? You say B, you can get it by saying that 3A plus B is going to be equal to the first term of the first difference. For us to get B, we say 3A plus B is going to be given by the first term of the first difference. Which in this case, what is the first term of the first difference? It's 1. And then we have 3 multiplied by 1 plus B, which is going to be 1. And then if you take this to this other side, it says which B is going to be equal to 1 minus 3. And you can see this one is what we did last year. There's nothing new here. So if you say B is going to be equal to minus 2. Now we need to also get C. How do you get C? A plus B plus C can be equal to the first term of the pattern. So you say A plus B plus C is going to be given by, what is our first term here? The first term is 2. So here we come and say we have 2. But now we already know what is A. Our A is 1 minus 2, which is B, plus C, which is going to be 2. And then if you add these two, you get minus 1. You take the minus 1 to this other side, it says which is C is going to be equal to 2 plus 1. It says which is C is going to be 3. Therefore, our Tn is going to be given by n squared minus 2n plus 3. Yeah, and then remember, this thing here, for you to be able to do something like this, they were giving us 4 marks. So it's 1, it's 2, it's 3, it's 4. Now, let's check. The next thing says which we should determine the 20th term. What does that mean? It means everywhere we see n, we're going to put what? Everywhere we see n, we're going to put 20. Okay, let's do that then. So we have T20. Instead of n here, we come and put 20. Instead of n here, we come and put 20. Instead of n here, we come and put 20. Then it says which we are going to have 20 all squared minus 2 multiplied by 20 plus 3. Now you type this in your calculator. Né? If you type this in your calculator, it's 363. Yeah, and then we'll give you 1 mark for something like this. Okay, let's look at this one then. Remember, from our example, we already saw that this thing here, it's a geometric. How did we see what it's a geometric? We saw it by saying term number 3 divided by term number 2. And then we said this is going to give us, it's 24 divided by 12, which gave us 2. And then we said term number 4 divided by term number 3. And then you see it's consecutive terms. I'm dividing consecutive terms. I'm not saying it's term number 4 and term number 1. It's term number 4, term number 3. And then if I do that one, it says which we have 48 all over 24, which is 2. Now, because this and this are equal, then it means which this thing is geometric, the constant ratio. Now, the formula that we're going to use, if it's a geometric, it says Tn is going to be equal to A R n minus 1. And then from here onwards, A is the first term. Whatever the first term is, it's your A. So what is our first term in this case? So we come and put which here we have 6. And then open bracket, this is a multiplication. In between there's a multiplication. And then our R, it's the ratio. What is our R? It's 2. And then we still have n minus 1. Now, here's what learners usually do. They then go on to say this one multiplied by this one. You can't multiply them. The exponents are not the same. So this is your answer. You stop here. This one is to the power of 1. This one is to the power of n minus 1. So you can multiply them. Laws of exponents. So here, now that you're done with this one, they say which we should determine the 20th term. What does that mean? Everywhere we see n, we're going to put 20. So we put 20 here, put 20, and then we get another mark for this one. Let's go to the next one, the combination. Now with the combination, how does it work then? We are going to have 2 general terms, basically. Again, we said number 4, it's a combination. And then we took term number 1, term number 3, and term number 5. Here it is. It's linear. Now, since that one is linear, what formula are we going to use? We're going to use the formula that says Tn is going to be A plus n minus 1 multiplied by D. A is the first term again. So we have 3 plus n minus 1 multiplied by D, which is 6. And then if you multiply here, it says which you are going to have 3. This one multiplied by this one, it gives us 6n. This one multiplied by this one minus 6. And then therefore, our Tn is going to be given as this one and this one, they are like terms. It says which we have 6n minus 3, like this. Okay, we check this one. This one here, it's a geometric. Just like our example, this one is geometric. We don't have to test it again. It's geometric. Now, if it's geometric, it means we are going to use the formula that says Tn is going to be A Rn minus 1. What is A? It's 3. Open bracket. What is our R? It's 2. And then it's n minus 1. Yeah? Now, this is where it gets tricky. Determine the 20th term. Determine the 20th term. This is a combination. If it's a combination, the example that we used last year, we said, okay, look at this person here. We're going to check them. Come and check here. This person here, it's term number 1. Okay? This person here is term number what? Number 2. According to the sequence, this person here, it's term number 3. According to the sequence, this person is term number 4. Okay? But let's consider only if we consider only the arithmetic, and then we look at this person who's term number 5. According to the arithmetic, this person is term number what? Look at this. This one is term number 1 again. This one is term number what? Number 2 again. This one is term number what? Number 3. So the person who's term number 5 here, when they get here, they become term number what? Number 3. If we look at this one here, the person who's term number 6, The person who's term number 6, if we consider only the geometric, this is term number 1 again. This is term number what? Number 2. This is term number what number? Number 3. Does that make sense? So this thing is similar to us saying which if a learner is number 1 in 12A, doesn't mean that the learner is going to be number 1 in all the grade 12s. They can be number 1 in 12A. But when we put everyone there, then they no longer become number 1. So yeah, we have to ask ourselves, okay, we're looking for term number 20 of the sequence. If we're looking for term number 20, is it an odd position or an even position? That's the question that we should ask ourselves. It's an even. Now, if we're talking about even position, we get them to geometric. Does it make sense? So because we're talking about geometric, because we're talking about even position, we're going to get it to geometric. So meaning we're going to use the formula that says Tn is going to be equivalent to 3 open bracket 2 multiplied by n minus 1. Now, according to the sequence, we're looking for 20 again. But when we go to geometric, the person is not going to be number 20. It's going to be number 1. It's going to be number 10. So we're looking for T10, which is going to be 3 multiplied by 2, and then it's 10 minus 1. Yes, what?
So let's say
Yeah, let's say they wanted term number 15 again. Yeah, term number 15, it says which we're going to get it to arithmetic. If we're going to get it to arithmetic, then you should ask yourself this question, which, okay, 15 divided by 2, what do you get? 7,5. Then it's term number 8 because a position cannot be comma something. Remember, this thing here is going to give you odd, then even. So in this case, what did I do? I said 20 divided by 2. 20 divided by 2 gave me what? 10. But if it was 15, I was going to say 15 divided by 2 gives me 7,5. Okay? And then you know it's term number 8. According to arithmetic, I'm looking for term number 8. Just like here, look at this here. You should see it here. It's visible. This person here, it's term number 5. But when they get here, they're term number what? Number 3. How did you get that? Let's check it. We said 5 divided by 2. What is 5 divided by 2? It's 2,5. We can't have 2,5. The person should be term number what number? Number 3. On the arithmetic is term number 3. On the sequence is term number what number? Number 5. So the person whose term number 10 on the geometric is going to be term number 20 on the sequence. So therefore, it means which our term number 20 is going to be. Type this in your calculator. What do you get? 1,536. Yeah, and then we do our activity. Come and do our activity. And then we're done. Simple as that. We are going to use exactly the same things that we're using then. Nothing has changed.